In the previous video we looked at AND gates. This time we're going to look at OR gates. As before, we will use a simple electric circuit to illustrate the gate. In this case, when the switch is off, the circuit is open, so the light is off. Once again, if we turn the switch on, the switch contact's closed, this completes the circuit, electricity can flow and the light goes on. Here is the circuit for an OR gate with two switches, which we will call A and B. Both switches are currently off, so once again the circuit is broken and no current can flow. The light is off. Notice that the switches are not wired one after the other like the AND gate. We say they are wired in parallel. Now we turn switch A on. The circuit is complete even though switch B is open. The light comes on. Now let's turn off A and turn on B instead. The circuit is complete although the electricity must take a different route. It makes no difference, the light is still on. If we turn on switches A and B at the same time, the circuit is complete. The current can flow through both switches, so the light is on. We can use a truth table to record whether the light will be on or off depending on the positions of switches A and B. In the table we will use the number 0 to indicate that the switch is off and the number 1 to indicate that the switch is on. For the light we will do the same. 0 indicates the light is off, 1 indicates the light is on. Now we can go through the four combinations of switches A and B being either on or off and fill in the table. If both switches are off, that is, A and B are both 0, the light will also be off, or 0. If switch A is on but switch B is off, the light is on. If switch B is on but switch A is off, the light is on. If both switches are on, the light is on. This is the completed truth table for the circuit. We call this an OR circuit because it requires either switch A or switch B to be on for the light to be on. Here's the symbol for an OR gate. It has two inputs, A and B, and one output. The inputs of the gate can take values 0 or 1. The truth table for this gate is exactly the same as before. If both inputs are 0, it is like both of the switches being turned off in our circuit. The output is 0. If either or both inputs are 1, it is like either or both of the switches being turned on in our circuit. The output is 1. The OR operation is sometimes represented by a plus symbol. It can also be represented by the logical OR symbol, which looks a little like a letter V. Sometimes the union operator symbol is used instead.